This is a talk on CI pipeline with Jenkins 2.0, and thanks for showing up this early. So a bit on the agenda. We're going to talk about Jenkins, of course, a little bit about pipeline fundamentals. How do we define pipelines? Some editor support, some security. I have a case study on how would I set up a pipeline with Jenkins, all the way to deploying to the cloud, running integration tests, rolling back in case they fail, and completing the upgrade in case they don't fail. And of course, that will be part of the demo. Who am I? I'm a senior engineer at Lego, where we work with microservice-based architectures on the JVM, at least on my team. I'm also on the GreatConf EU conference organizing team, an external associate professor at University of Southern Denmark, and I occasionally get time to block the Grails diary. Not as often as I would like to, but still somewhat regularly. So Jenkins is a good old friend of mine. Also, sometimes friends tease each other, and some of the points I'll get into today. But Jenkins is used for continuous integration and also for continuous delivery and deployment. So you all know continuous integration, but just to recap, it's the practice of merging all developer working copies to a shared mainstream several times a day. And continuous delivery and continuous deploy is to ensure that we at all times can deploy some reliable software, and he can help us with that too. So, pipeline fundamentals. Why would we want to do this with Jenkins? Well, it's really easy to build all branches. That's taken care of as long as we have a Jenkins file on the branch. We have the CI pipeline as code. Back in the days when I started using Jenkins, I did a lot of GUI clicking around. Oh yeah, and then I need to remember this. And the way to configure a job was to copy one job over and see it's somewhat similar here, and you always ended up not getting it right because you forgot something that you'd changed from one project to another. And trying to make an upgrade across all of the projects was just a real pain. Pipelines today can survive restarts of the Jenkins master, so they're more robust. We can stop and wait for human approval, and I have a demo of that. We can do fork joins, we can do loop, and we can do work in parallel. And it supports custom extensions to its DSL. Well, then you could ask yourself, why not? Well, there are other CI systems that do this very well too. Drone.io, Travis, all of those. I'm not going to touch really on those. If you have good experience with those and you're comfortable, well, stay around. Use the tools that you like. One of the things I think is a little pain is whenever you Google something on Jenkins, you need to be crystal clear on what syntax do you want, because they have two different syntaxes. One is the declarative pipeline, and one is the scripted pipeline. Both of those are under the hood the same modules, but the syntax is significantly different. And I'm going to treat almost solely the scripted pipeline because that's the one that's the most pure groovy. And why would we want to do it? Of course, because it is groovy. So, scripted pipeline 101. This is a very small sample, but this is an entire pipeline. So a node defines the executor that we want to build our job on. We can give that parameters, say this should be a type Windows, and it will adhere to that. So it'll find an executor that has that tag. The stage is a stage in the pipeline, and we get those nice stages, so we can see exactly how far did our pipeline progress until a fail occurred. And the steps are the ones that actually do work. So here, it's an example of just shell executing the Gradle wrapper with the build. So that's it. Now you know a lot about Jenkins pipelines. This is a complete one. So when we have defined stages, we can get an overview that looks something like this. And I'll get back to why do I have every second one of these as just being done in the first step. So I mentioned that there is this declarative pipeline, so just touch base on it really fast. It's it starts out with a pipeline. It must be there as a tag. It doesn't really do anything besides declaring this is a Jenkins pipeline. The agent step is compared to the label on the other on the scripted pipeline that says which label do you want this executed on? Do you want it on a Windows or, like in this, any? Then there's the stages, and each stage again have steps, and the steps there are defined exactly like in the scripted pipeline. One nice thing here is that they have the post construct that makes it easy to do things in case of errors, or like here, always. So that part I really like about the declarative pipeline. The declarative pipeline were made to give a simpler and more opinionated syntax, as not all Jenkins members, sadly, are Groovy experts. So the scripted one is still valid, and is still completely supported, and it is as close to real Groovy as you get. There's a few differences here and there. For example, because pipelines needs to be able to restart in case the Jenkins master fails, you can't use the each iterator on a collection, because that's really not restartable. So there's a few things, but I have rarely ever met any of those. The scripted pipeline, however, is very flexible. You can do just about anything. And it has more of an imperative programming paradigm. So, writing pipelines. There's multiple ways you can do that. So in the web UI, you do have support, and you can just type in your pipeline there and save it as a file. That is okay when you have to get going, try to start up. You don't have to commit to push and try to get Jenkins to build something. But as soon as you think your pipeline is somewhat done, you should definitely put it into source control. That's one of the strong sides of this way of doing it, that in case your Jenkins master dies, you're not depending on files that is located just on that single place. So there's a snippet generator if you want help. That is built-in support for many of the steps, and you can choose which build step you want, and depending on the build step you choose, you get different items you can check out. And this is really awesome. And most of those actually generate correct syntax. But there's a few of those that does not generate the correct syntax, which means you have to figure out what went wrong, reading a lot of documentation, and occasionally find the right solution. A few notable features that I won't have in the demo, but I think it's worth a short mention, is parallel steps. It's really simple and easy to do parallel steps. So if you have functional tests that run for a long time, you might want to run those in parallel with your unit test. So you get them started, get them running, but you'll get the fast feedback in case your unit test fails. So this is an easy way to do it. You have locking, so in case you have some kind of element that you need to make sure no one else is messing around with this. It's also really easy to define the lock. It says, all right, I want the staging server to be mine and no one else. I mentioned you can put in node labels, and that's really powerful if you have different built environments. If you have something for Mac, something for Linux, something for Windows, then it makes sense to define which type of node do I want the job run on. Editor support. Well, this is just Groovy, so the first thing you should do is make sure you have informed your editor this is in fact Groovy. Then it'll try to help you as much. But this is a Groovy DSL, so you don't get that much out of the box. But Jenkins is aware of this, so they have made a GDSL file that takes care of most of the build steps. And you can download that from inside Jenkins and place it in source main resources, and your editor now has at least some syntax auto-completion. This, of course, only works for the steps that is defined, so whenever a new plugin is installed, it might not be supported in this file. But it's a great help when you're new and writing pipelines. When you write your pipelines and they're defined in the source code repository, well, since you can do arbitrarily Groovy, that seems like a really big security hole. Luckily, it's not, because you are missing permissions to just about everything. You're not allowed to do a lot with your Jenkins file that's just checked into the repository by default. It's very unprivileged, it's very sandboxed. But you can install the script security plugin, and there you can, on a command basis, define exactly what is allowed. So you get an easy overview, something like this. It says, all right, so your script has tried to perform these actions. Will you approve each of these actions? So in this case here, I could choose to improve run wrapper get raw build. It makes sense that it's not available by default because I have access to the internal workings of Jenkins in this way. But you can allow anything with this plugin. You can also define global libraries. So if you have common steps that you use across multiple pipelines, first of all, to keep your pipelines dry, that makes really good sense to have them as a global library. And a global library is considered a trusted resource. So that doesn't run in sandbox mode. That has access to everything and can do everything. So let's go to a case study on how would I set up a deployment pipeline nowadays. So first 3 steps is fairly common. Let's do some static code analysis. This is a Groovy conference, so that means let's run code narc on the project. Then let's run a set of unit tests, and let's measure the code coverage just to make sure that we are in fact testing something. Once that is done, on my team, we break up a user story into multiple tasks, and each task in itself might not be worth a release and doing more with that. It might be that I in Grails have generated the logic for the service method. There's no integration test. It's not called from anywhere. That makes sense that I want to run the unit test, but I don't want to really do anything more with it until I have actually exposed it. That's why we have this human interaction that says, do you want to wrap this in a Docker container and continue on deploying this to the dev server and run your integration test? And it also makes up for a nice example on how to get input for Jenkins. If I approve and says, yes, please continue, I want to build the Docker image. I want to deploy it to the server, and I want to run a set of integration tests against the deployed service. So compared to Grails, where your integration test typically uses an H2 database, and you might run with a Postgres in production, well, it is true that it is integration test, but you're not really testing the real integration against the real services. That you're doing when you do it against a deployed service. This could be one of multiple microservices in a stack that works together, and doing it with a deployed service, you can guarantee that it will not break any dependencies or any contracts with other services. So I think this is a very powerful way of running integration tests. And with a container platform, an orchestration platform, I'll demo today, that's called Rancher, we can, in case the integration test passes, approve it and say, all right, that's fine, that's the one you want. Or we can roll back, and we roll back to the previous version and let the developer know, you need to take a look at the integration test because something failed. Don't know what, but you need to manually do something. So first step in a pipeline like this is check the code out of source control. And with my team, we really like the idea that we can have the CI skip as part of the commit message, and then the pipeline does nothing. And in the old Jenkins, there's a nice plugin for doing this. That plugin, sadly, has not been upgraded to the pipeline yet. So we need to do a little hacking thing. So first thing is, check out SCM, checks it out from source control management. That's really elegant and does the job really well. The part about the CI skip is a little less elegant. So what I do is, I try to read with git log format, get just the last of those, and get that in last message, and figure out, does it contain CI skip? And in that case, set the build to aborted. Then you can see that the if statement down there where we check is it aborted will return. That seems like an odd place. This is a Groovy DSL, and one of the things that we need to take care of is, if I return from inside the stage, I'm just returning from a closure or a method. So that doesn't abort my pipeline. That's why this, where I need to abort, needs to be in main scope. Then I do a bit of cleaning just to make sure. This shouldn't be necessary, but just to be safe. And what I do is I stash all the sources for later use. In case I have a job that I want to execute on two different executors, it might be 2 different separate hosts, doing the stash means that I can always pop the stash on whatever source, whatever host I have, and go from there. Static code analysis is simply running CodeNarc main and CodeNarc test using the Gradle wrapper, and then I try to publish the HTML result. So in case something is wrong, I can actually see the result. And if it's not wrong, well, I can show to the other developers that, yeah, it's good. CodeNarc doesn't complain. Running the unit test. So there's a disclaimer here. I'm using Gradle for just about all of these steps. That makes sense. A lot of these things can be reused, and I can make them in Gradle plugins and make sure that they're just available across projects. So running the unit test is just Gradle wrapper test, and then use the JUnit result archiver to store the output of these. Another stash here says, all right, so I want the Jacoco exec file to be saved for code coverage. That means, again, I can run on a different executor as long as I unstash this. So for the coverage, I can unstash the source. So I have the sources, and I can unstash the code coverage, which gives me the Jacoco exec file. Run Jacoco test report and publish that as HTML. Error handling. So you're all Groovy developers, I assume, since you're at this conference, or at least moderately interested in Groovy, which means error handling is just using a try-catch. It'll throw an exception, you can catch it, and you can set your build to failure, and you can do everything that you want. Inform by mail, use a Slack integration, send an SMS, or whatever you want to achieve with this. And then throw the exceptions so your build definitely will fail. Next step was the user input. So, do you want to release for Docker? I can set up a timeout that says, all right, if I haven't replied within 2 hours, then just assume that I don't want to do anything. So this cleans up rather nicely. The input plugin for Jenkins has luckily been updated recently, so that now you can also get who approved it as part of this. Up until recently, you couldn't, in any sensible way, get that information. But now, if you define that you want the submitter parameter, then you can get that information. This is one of the pain points where I really think, oh my God, didn't you know that this was Groovy? So here, the choices is a drop down, and I have honestly no idea why this is not a list in Groovy. Why does this need to be a string that is separated with a new line character? I find that a severely odd choice. And the documentation for this is limited to none. So it took me at least 4 tries before I got this one right. And this was also one of the steps where if I used the assistance in Jenkins, it didn't provide me with the right syntax. So, not so long ago, I still wanted to have a registration of who actually did that, because we uploaded documentation for the release, and it could be done. And this was also why I had all of these weird methods that I needed to approve. So you could get it, but you needed to get all actions and find an approver action and assume that it was the latest one. So it's not necessarily correct if 2 people approved roughly at the same time. But you could get this. The non-CPS here is an indicator that this step is not parallelizable. So it also means that Jenkins can ignore this method whenever it has to do a restart. It can assume, all right, whatever happened in here, I can't try to save the state of that. So assume that's just broken and try to run all of it again. All right, we want to release a Docker image. That's the next step. So when I do releases, I really prefer the tag to be on the branch that is actually released. When Jenkins checks out code from source control in Git, it ends up in detached head state. Detached head state and tags is not the right thing to do, because you just have the inability to push, because you're in detached head state. So first thing you need to do is actually check out the right branch and pull. This is a little brittle here because you could potentially end up that another commit has sneaked in here. I haven't found a good solution to that. So that's again one of these, well, that's interesting. I do understand the choice that they have made from Jenkins that, all right, let's go in detached head state so we don't by accident push anything that we don't want to. So as you saw before, I can I can choose to release a patch, a major, and a minor. So this is plain groovy. I just do a switch on the release type and invoke the corresponding Gradle job. And in case something has went wrong and I didn't get the right input, I can also do a failure there. Deployment to development. Well, I've done Gradle deploy scripts, and now on the release type, I already had a switch where I knew it would be one of the 3 valid ones, so I can just use string interpolation. I'm safe with that now. Then, once you've informed your orchestration tool that you want to deploy, it might take a few minutes before that had pulled the new image and make sure that it has started up. So, since we can't do backwards hooks, then this is done in a polling way. So every 15 seconds, I think, I've made a Jenkins job that just pulls. It says, all right, are you done? Have you been upgraded? Have you been upgraded? When it replies upgrade, then I return. But that's also a little brittle. So nice thing here is we can use the timeout that says, all right, if it hasn't deployed in 5 minutes, something must be wrong. So just fail and abandon. If it works, just because the container has been deployed doesn't mean that the application has actually started up. So my demo is with the Ratpack framework, so I could likely switch this one off because starting up a Ratpack application is blazingly fast. But some of the frameworks that we work with might take a few seconds. So just to be safe, let's wait for 5 seconds before we move on. And the sleep command, of course, makes a good demo. So the integration test is where you can connect multiple jobs in Jenkins. So the integration test that runs against a set of microservices is, of course, its own project. And being its own project, it also has its own job and its own Jenkins file. So what I just do is I reference the integration test Jenkins job and say, will you please build this? I want to wait for you to finish, but I don't want you to propagate the result. So in case you fail, you shouldn't fail my build immediately. Well, why is that? Well, I want the result of the integration test and take action on those. So what I want to do is finalize, and in case the test passes, I want to inform my orchestration tool that that's okay, you can improve this deploy and we can move on. Or I can do a rollback in case that something failed. And I want to go back to a consistent state so that others that work maybe on the same services will know that that stack of services is actually valid. So that was one large Jenkins file for just one pipeline. And a lot of these steps seems like, oh, if this was Ratpack or this was Grails, they would be identical still. So to make the Jenkins file dry and to get rid of the security issues, we can make global libraries. So to make a global library, you need to configure it in Jenkins that you actually have a global library, and it's just a Git URL that you can put in there and name it. And you can decide, should just by default just be available for all things. And I'm lazy, so I do that. I'm not importing explicitly a library. I just say, well, my toolbox with all of these tools that I use for just about every single job, that's okay. They are available. So the way you can do this is, it's by convention. So you need to have a wars library in there, and then the file name defines what can happen. So here it's called ci-skip.groovy, and that's relevant because that defines the ci-skip method. It's actually a closure. So the way a shared lib looks like is you need to say def call and then the code you want executed. And here the syntax is completely identical to the pipeline syntax in the scripted one. So this code, I've already shown you most of it. It is just now wrapped in a call method. That means that the first step of our CI pipeline can be shortened down to CI skip. We're just calling the method, and if we extend this library with all of the functions, then our Jenkins file becomes really, really short and very, very readable. There is one extra extension that I think you should be aware of. The Blue Ocean sub-project of Jenkins is trying to build a completely new user experience based on top of the pipeline plugins. So it has a different graphical UI. For the declarative pipeline, it even comes with a still beta version of a pipeline editor. Well, I'm a Groovy person, so I can script my pipelines, but I see for new users that this actually makes sense. And I think the overall UI at least have given Jenkins a bit of an upgrade. Let's see. You can try this out yourself. It's really easy in Docker containers. There's just one thing you need to be aware of. That is, if you want to do the release a Docker container from inside a Docker container, well, that is a little painful. I didn't manage for this demo to get it working. There are people who claim that it can be done, so that's probably because I'm just lazy or stupid or didn't find the right location. But of course, you need to allow the Jenkins container to access the native Docker client and do kind of weird stuff. So this image here is provided by Jenkins. So it comes besides Jenkins with a pre-filled Git job, Git repository, and the pipeline job generated. So it's really easy. I've added in a few slides for the literature. So now it's time for me to shut up and show up instead. So I have prepped a bit of demo here. Maybe this will work. So I think I'll switch to shared mode screen because that makes it a lot easier. And I hope this works. All right. I think I'll unswitch from the mirrored display. All right, so we're back to here. So what I made is a very small Redpack application that is a greeter. So if you don't send a name input, it just says hello Groovy person. And if you give it a name, it says hello whatever name you gave it. So almost a hello world example. This is running on localhost, but I have deployed this in the cloud. So we can do the same thing here and say name equal Spain, and this still works. So I mentioned to you that I have a container orchestration platform, and this is where the Docker containers are being managed from. So as you can see here, I've just finished an upgrade. I'm now on version 001 of this very important Redpack application. So let's make a small feature for this. So I have done a bit of cheating. This is on the deployed one. So we don't have any Greach endpoint here, but I do have this on my local one, on localhost. Greeter. So if I ask for Greach, it'll tell me it's an awesome conference. So I'll stop this one locally and say git diff. Well, all it is I've inserted an extra get thing in the Redpack file. So don't do this at home. You should use an external handler. But for this example, So now this is stored in Git, and we can go to Jenkins. I what?
You haven't really committed. If you check your console, you will see that you didn't commit.
Oh yeah. Git add. Thank you very much. Now it's added to Git. So this is the ordinary Jenkins, and I have my demo app here. And I can even log in. So as you see, it finds the different branches. So on master, I have a somewhat stable trend over the last couple of ones. This is just a Git repo on my local computer, so I haven't set up any Git hooks to try to get Jenkins to build this automatically. Of course, you'll do that in a real setup. So there's a build now feature there. And as you can see, we start building this. If you like the old textual-based output, that's of course available still. So now we're running the code.nart main, the code.nart test. We should get back out to the main page. So now, do we want to release to Docker? Yes, this is a very fantastic feature. So let's release a... Oh, this is new functionality. That must be minor, right? We're not Grails, so... So this is the step that takes the longest. And I'm really hoping that the Wi-Fi here will assist me just a little bit. Because this is where it will create the Docker image, and I'll have to push it to my local Docker repository, which is in the cloud. So that seemed to go very well. So as you see here, we're waiting for the status to be upgrading. And if I go to Rancher, see here, whoa, failing to pull. That's bad. So in 2 minutes, something will really fail in case this doesn't get pushed correctly. So, as you see, I apparently didn't sacrifice enough to the demo gods. Yeah. Pushing image with this one. Oh, it's pushing a major. Oh, that was bad. So what we will do is, all right, in case this major is then available, let's cheat. That's what the demo is about. We can try to cancel the upgrade, and we'll do a manual upgrade. That's available. You see, the container tool still has the old one running, and the new one that made an error. So this is a very robust way to actually deploy, because it spins up the new container before it allows network traffic. So it will detect some of these errors. It's not like in the old days when you had to stop a Tomcat, start it again, and suddenly things stop working. So that's one of the benefits of running a container tool. What is not so robust is if it is not in fact available. There we go. So now we want to do an upgrade. So here, 1.0.0, because apparently it was tagged wrong. And now I just mentioned that it didn't stop it, but you need to do a check mark, which I failed in doing. So, as you see here, I'm at least listening to cancel upgrade to what is happening. Waiting is upgrading. So, when it says built successfully, it means, all right, now it was actually finally upgraded. And that means it is now running the integration test in this particular job, which doesn't take that long. So no failures. And we have a success. That means if we go to the tool here, you see that it is now active. If the active thing here means that it has actually been approved. And if we're lucky, this should actually work now. In case I didn't make a typo. Damn. Is it double slash? Yeah, sorry for that. This is not the best angle to show. Is it there? Yeah. There we go. So we now deployed a new feature for our service here. Right. So I think there was one more tab I would show. So the Blue Ocean is simply just a plugin that you still have the old Jenkins in behind, but you can switch to the Blue Ocean system, and it's really easy to get started with it. The way that you create a new job here is also extremely easy. So let's see. Well, new item, top one. So you enter the name. You say, I want to have a multi-branch pipeline. And then all you need to fill in is, all right, this is in Git, and all right, so this is the repository. What's the mouse? So this is a repository path. Type this in. So this should be GitHub or whatever, but I try to make as much as possible not depending on the internet. So see here, it's scanning the pipeline, and immediately it shows up which branches there are and schedule them for building. So that is all of the configuration that you need to do in Jenkins in case you have it stored as pipeline. Migrating from one Jenkins instance to another makes this fairly simple. So, any questions on the Jenkins pipeline? So to reply my original question from the abstract about pain points, the documentation on a lot of these new features is a little rough. There's quite a number of the old plugins that is not supported in the new pipeline syntax. But the most important ones are there, and since this is Groovy, you can do a lot by the global libraries or just defining it in your source code. And I really prefer to have much of my build logic in Gradle plugins, so I can just import one line there and have that available, because when you use Gradle, you can run it locally from your computer. A Jenkins file can only be run on Jenkins. It's not a really Groovy script that you can run on your computer. That's one of the things that would have been nice.
So, how do you have support for non-supported plugin? Is it a part that you should do in the source code of that plugin, so follow some SPI or something like that, or is it part of the pipeline plugin repository?
The individual plugins add support for pipeline, but it's not an area I've gone into. I think developing your own plugin in Jenkins is not trivial at all. So I have instead tried to remove as much logic as possible from Jenkins and place them in Gradle files and Gradle plugins. Also, when much of this logic could be placed inside a single Gradle plugin that takes care of all of the versioning and communication with your orchestration tool. And that makes it available for you to work with it on your local machine. Right? Any other questions? I hope no one over in that area, because I can't see you. It's too dark. Maybe you're sleeping. All right, then thank you very much.